Hello and welcome to Apologetics 101. I'm your host Brian, and I'm glad to see y'all here, enjoying videos and content that I'm making. We're here today again to talk about the so-called heat problem. This is the last video I'm going to do for a while on it, and I've been debating a lot of the critics in the comment section since I proposed my original model, the Geothermal Feedback model or the GTF model, which so far has been successful, but the critics don't like it very much, which that's kind of expected, so I'm not too worried about that. But it's had a lot of mixed reactions. Some YCs that have held their own position on the matter had issues with it, or at least David did. I haven't had any other YCs that really complained, but that one particular YC did, because he has his own model on it and he doesn't like anybody else's model but his own, and he thinks he's correcting us by challenging our models, but he actually doesn't correct us on it. He just well, anyway, I'm not going to go there. I don't like debating other YCs on their individual models. He's welcome to take whatever model that he favors. I don't really care which model he takes. But uh, but he does have a problem with my model because it's not his. So he's different from me. He likes to sit there and try to debate other YCs. Um, and he denies accelerated nuclear decay, which is something that most YCs accept, myself included. Um, but he rejects that. He's one of the handful, like small handful of YCs that deny accelerated nuclear decay. But like I said, he's welcome to take whatever position he wants to take. David does. You're welcome to take whatever position you want. But I do stand squarely within mainstream YCs, and I do accept that accelerated nuclear decay happened. I think that the evidence for accelerated nuclear decay is extremely strong, very powerful indeed. But um, but along with that, there's all sorts of other heat sources, including the CPT, which David does agree with, and of course a number of critics come on my channel. Some just like in and out, and then a couple of them do so pretty regularly if they hear a topic that interests them or something. Um, these two particular critics that have come on my channel that fiercely tries to debate me on numerous issues, and it's not even too uncommon to see these two teaming up. One time, on this particular debate, I actually saw Graham practically beg AB to help him debate me. So I mean, he didn't come out and say that, but he insinuated that he wanted help from AB to debate me on it. But AB was more restrained at the time. I think he has some other stuff going on or something like that. But he's now trying to get a little bit more into the fight, and I guess Graham likes that because Graham wants, to team up with somebody to go against me. So it's like, wow, I knew I was good, but I didn't know I was that good. You need another person to help you debate me. Okay. All right, all right, all right. I'll try to simmer my ego down there. I'll try not to let that get to me. You know, you can't debate me by yourself. You need help. Okay. No, I'm just kidding. I'm just messing around. But any given case, they do try to challenge it, and I've been debating them since I first dropped the original video, which will be linked in the description box below. It was linked in the last video as well. The death of the heat problem video, which I dropped, and I've been debating them all month long. That is not over exaggeration. All month long, I've been debating them, and they've been given a whole month to try to refute my model. Um, and all month, I watched them misrepresent my positions and my model, um, uh, make faulty assumptions about my model that wasn't true, or say, or even give out silly stuff think that maybe that I believe that maybe the volcanoes were shooting it straight into space, which I wasn't arguing. Um, uh, Graham later would say, "Oh well, I was just asking as a question." Yeah, initially he asked as a question, but then later I think it was to AB, he sits there and insinuates that or actually mentions that he thinks that this was my position, that that's what I'm arguing for. And I'm like, no. And then even insinuates it later when he spots a typo that I did in one of the slides where I talked about the non radiation, and it had on the conclusion slide, I had a bunch of stats, and these stats were on that, and one of these stats was really supposed to be for the infrared radiation or the non-infrared radiation, but I put in space on it because that's I put the other one on there and it was a typo. I mistyped it. I didn't realize what I had done at the time until Graham pointed out. Said, "Okay, that's a typo. I'll go correct it. It was on one of my slides, and it wasn't." And this is another problem that happened, but I'll get to that in a second. But any given case, he sat there and took that and thought, oh, so he believes that radiation or that he can go out into space without being radiated into space, without going through radiation or Stefan-Boltzmann's law or something like that. And I'm like, no, that's not what I said. I never argued that. And then he tried to insinuate that back to the whole volcano, shooting it straight into space. And it's like, no, 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 no. It was a typo. It was an accident. Well, I don't believe it's an accident. I'm not lying to you. It really was an accident. I didn't realize what I'd done when I did it. And then I corrected it. Told him I corrected it on my slide. And then, he argued that for some time until I don't know if I convinced him that it was an accident or if he just gave up on it. I don't know. But either way, it was an accident. It was on one of the slides. One of the mistakes that they kept making is what's called a categorical error. A categorical error is technically not a logical fallacy. A categorical error is a mistake in the way you're defining or treating certain categories. Like you're taking um, uh, more than one category, two or more, and you're conflating them with each other and treating them as if they're one category, as if they're the same category. It's kind of like the equivocation fallacy is in logic, except it's with categories, and it's not a mistake in logic per se. It's more of a mistake in how you're understanding these distinctions between these categories. And and one of the things that Graham had trouble understanding is that me making multiple videos is not the same as me having multiple versions of my model. My model never changed. My model stayed the same from point A to point B. Even now, even in this video, it is the same. Now, I do sit there and break it up into three phases in order to make the test more applicable to my system. More on that in a minute or in a little bit. And I do that, but the model itself is the same. Now, how I described it is also the same. In those three phases that I'm going to talk about here in a little bit, they're the same. Okay, the description doesn't change. I just felt like these breaking it up like this in three phases better described it. Plus, when I tested for it, it would be able to employ the entirety of my system. The the fact that I'm able to take my entire system and be able to apply it to this, because that was an issue that came up later, and I'll discuss that here in a little bit. But that was one of the mistakes that was made as well. They kept Graham was like, "Well, you got three different versions of your model." No, same model, same exact model. My model works, actually does work. I've tested it multiple times. Now, with that said, there was one particular test that I did recently that did not actually uh, was not actually reflected the reality of my model. I didn't actually think about that. At the time, I just kind of did it. I do these kinds of things out of curiosity and interest because, this stuff interests me. So I'm like, I wonder if I apply the math behind Stefan-Boltzmann's law, the equation and stuff like that, to it, what would come out? And so that's what I did. But what I didn't expect is that there was no way to take the the entirety of my system and apply it to one component, because when you do that, you literally isolate that one component away from all the other components. What makes my system so effective is the fact that it's a combined effort of all these different mechanisms and components. That no one particular component, no one particular mechanism has to actually take on the entirety of the burden of the heat during the Genesis flood. That's what makes my system effective. Um, but in the process, I had forgotten about that. And ChatGPT does this calculation of 150 zones. Now, these were never made public in terms of video. I mean, they're in the public comment section, but they were never made public in the sense of me making a video on them. I was going to, but I ended up abandoning the project. I'll get into that in a little bit. But essentially, what it was is I did the test for 150 zones. You know, I had ChatGPT split the entire circumference of the Earth in the atmosphere and stuff into 150 zones. And I didn't realize there was issues at that time, but I'll get into that in a second. But at the time, I thought, well, I'll just split it up, you know, and have ChatGPT run the calculations and the math and try to show that I can use Stefan-Boltzmann's law, which I can, and I do end up demonstrating that in another test. But in this particular test, ChatGPT does say that did claim that I had like over 99% of it was removed in the flood year, and somehow I don't. I think that there was a mistake in it when it did the actual table. It didn't actually give me a complete list of sources, or it assumed my system in the 99%, but then when it did the table, it did something different. I ran these numbers recently to sit there and see what was going on with it, and apparently it did not actually apply my system um, as a whole. It was impossible to do it the way I was doing it and still apply my entire system, the effectiveness of the system, to it. It just would not be possible to do that on an independent component. Because when you do that, automatically you have to assume asymmetrical approach. You have to assume that I'm taking all this heat load and then I'm calculating it into Stefan-Boltzmann's law using this equation and the constant and and then and doing this on also a set static um, uh, zones. Even if I change the size of the zones each and every single time, it doesn't really represent the fluctuation that you would expect from regions of volcanic activity and differences in temperature and size and constantly changing during the flood. Another thing ChatGPT did was he was starting it over with zero heat. None of the heat was rolling over from the previous phases, and that wasn't realistic. And that's the reason why I ended up abandoning it. Now, a critic named it was AB. A critic named AB does a calculation of one of the categories. I think it was just the raw jewels section, one of the categories, and he came up with a number that was way less than what ChatGPT had told me. And so it was like ultimately like less than 1%. And so he's like, oh, so this must the test must not be, or the assumption was that the model must be flawed. That another category error that confuses the test with the model. What is the test was flawed, not the model. What happened was that the test did not realistically reflect my model. It did a whole bunch of stuff wrong. It started each phase. I did it in 6 phases, with each one 2 months long, which also wasn't realistic um, since this is a very dynamic model. It's constantly changing, um, and as the heat builds up, it's at the same time the cooling mechanisms and everything is actually scaling to match. And so the heat's constantly building up, the cooling mechanisms are constantly increasing, and then it'll reach its peak. And then, of course, all this time, mantle convection is going super, super fast. In the new calculations that was done, it was found to be 1.70 billion times faster than modern rates. That's at its peak, though. Okay, keep in mind though, because this is always constantly changing, even the numbers themselves are going to probably represent the maximum of what we'd expect. So, uh, 1.7 billion, just to kind of illustrate it, because it's constantly changing during the course of this. 1.7 billion would be the peak. That means when it's at its hottest before the cooling mechanisms really take effect to a point where everything starts to really reduce. So the 1.7 billion, 70 billion, 1.70 billion times faster is at its peak. So obviously it's not doing that here or here. Okay? Because here it's building up the heat, so it's getting faster, but it's not obviously starting out at 1.7 billion. But here it's getting slower because the heat itself is alleviating, so you're losing more heat, and the more heat you lose, the slower it's going to get. So the 1.70 billion times faster is when it's at its peak. That is the fastest it gets to. That does not mean that that's the slowest it gets to. It will go slower as less and less and less heat is building up, or more heat is, being thrown out by volcanism on a global scale, and that sort of thing. And so this model is constant. This system is constantly changing. It's a very dynamic system. It's a positive feedback loops, and it's driven by the heat. It's thermally driven. Okay, so trying to add more heat to it is not going to work. This model was never intended to be dependent on the math. Even the five major sources of heat were not intended to be exhaustive necessarily. Obviously, I'm not including sunlight, heat, or anything like that. It's not meant to be exhausted. It doesn't have to be. The object of it is just to kind of illustrate the fact, because this is not math dependent. The math is used secondary in the model, not primary, because the validity of this model is dependent on the system itself. And, as I'm watching these guys struggle with all this, their struggle to understand how mantle convection works. In terms of heat. Graham originally sounded like he understood it, and then later he sounded like he was denying it, at least sounded like he was denying it, and then later still he tried to say this was ridiculous. That's his words. He said it was ridiculous, and I started giving him evidence, even peer review evidence of mantle convections being affected by the heat. And he said, "Oh well, you're just straw manning me. I don't. I'm not saying it can't. That mantle convection isn't affected by the heat. It's like you just called it ridiculous when I said it." And then he's like, when I said, because if it's affected by the heat and it got this much heat, and you calculate that in using Rayleigh's number, it comes to 1.70 billion times faster than normal rates. I mean, I mean, how do you account for that? And then there's even times when he will set their act. Um, Graham gets double. I don't know how to explain this. Trying to use the phrase that usually people come up with, like speaking out of both sides of the mouth. He does this a lot. Like he'll sit there, act like he's arguing one thing, then he'll say, and then he'll argue something different later when he's challenged with it. But he sounded like that he didn't understand, like AB, for example, didn't understand why whenever I realized that ChatGPT had inflated the heat sources, right, to over three times greater. And then when that heat source reduced, then this reduced the speed of convection. And they're like, oh, why is that? Or AB start wondering, why did that reduce? I think he just kind of assumed assumed that I was doing it to reduce the friction, but I wasn't because I didn't mind the friction because any additional heat is just going to help my model. It's not going to hurt it. So I wasn't afraid of the heat in the first place. I even factored it in the next time around. But just to show you that the heat is not going to bother me. Any additional heat is just going to strengthen this model. So I wasn't worried about that. The reason why it reduced is because it was less heat. That's why. And then Graham later just act like he didn't understand this, even though it didn't make no sense, and he admitted to understanding that convection heat speeds up, and you can factor in the Rayleigh number. He knew all about that. It's like, okay, then why are you acting like this is wrong? It's not wrong. You know it's not wrong. Um, but he's like, well, it would cause this and this and this. No, no, it doesn't work that way. But anyway, yeah, I'm just breaking into the normal course of the video. Since I made this video, I actually have been working on a series of controls. Um, if you don't know what a control is, in science, a lot of times they use controls. They don't have to use them. Um, Sometimes critics get misunderstand that they think they have to use controls in order to make do good science or be truthful with their experiments or anything like that. That's false. They don't have to use it. They're not required to use it. Um, you could even do a peer review paper and never want to use controls in your studies. It is possible, and secular scientists even did this. So it's just kind of special pleading when critics assume that we have to do controls. However, a lot of times scientists do controls because even though they're not required, they're helpful. They are extremely helpful in trying to prevent biasms from entering in your experiments. Try to help with understanding certain aspects of your experiments, making sure, testing your software, testing your equipment, make sure everything's functioning properly, testing your methodologies, things like that. So controls are helpful. They're not required, but they're helpful. And so a lot of scientists do utilize controls when they're doing their experiments. And so I decided, well, I need to do a series of controls. I'm not going to really get too much into all the controls that I did. I did do a lot recently. Um, but I'm not going to get into that. Maybe I'll cover that in a later time. That's not the point of this insert here. The point of this insert is really to discuss a particular type of control that I had done recently and some information that I had found out, or at least some information that end up getting tested for. So a control is basically a very specific type of test that you're doing on a specific item or items within your overall experiments. So in other words, I'm not testing for my model per se. I'm more testing for specific aspects of it to make sure that what I'm saying about it, the methodology, the conclusions I'm raising, things like that are accurate and legitimate. And so I did a series of tests. One of the series of tests I did was to look at volcanic eruptions to see whether or not if you apply the feedback loop system, like if I look at a volcanic eruption and you apply Stefan-Boltzmann's law and how much heat within that volcanic eruption was actually, as a result of that positive feedback loop, that was actually the result of releasing into space. That release in space. Was it, 70%, 65%, 20%, whatever, you know, and I wanted to see how much heat was relieved into space in order to test the the position I've argued for that most of the heat would have alleviated in space. The feedback loop would actually be effective in helping with radiation release, with the removal of heat, as well as being able to uh, get heat to the point where it can be removed effectively. within my model. And so I basically was testing for this, and I found some interesting developments there. I actually did see that it was like with the feedback loop, there was a huge increase. But here's the thing. It only happened when there was a lot of heat involved. When there was a lot of heat involved, and the way I tested this, by the way, is I would sit there and test it with, the feedback loop. I wanted to see with a positive feedback loop in the volcanic, how much heat of that volcano was, or that volcano system was released in a year, in a year's time. And then I would test the same amount of heat, how much was the same amount of heat apart from the volcanic eruption, from uh, uh, apart from the positive feedback loop, the same amount of heat, how much would normally leave normally? And I tested for this, and sure enough, it was very low when it was not had no positive feedback loop, and the positive feedback loop was very effective. But it was only that way when there was a lot of heat. When it was a lot less heat, guess what ended up happening? The reverse happened. Like if there wasn't that much heat produced, the normal way would produce 100% out. Why the positive feedback loop was slower because they had to go through multiple processes such as uh, water evaporation, which of course slows down with not heat. If there's not that much heat, it would be really, really slow. And going through these processes would then slow it down. So it used much less heat. And this is interesting. And I sat there and tested for it. I had to use to test properly to get it as close to I could. There's no way I could ever get it to the scale that was in the global flood. That's impossible. But I was trying to get it as much like it as possible. So I set to start using super volcanoes that were on like a series of volcanoes. They erupt at the same time, and I even started looking at specific layers in the geological strata, what secularists would call the geologic column. And I started looking at particular, volcanoes that would have erupted at the same time, roughly within a particular layer, a particular ash layer or something of that nature. And I started to look at that and to see, and I wanted to know how much heat did that system or systems, that were going off at the same time had produced, because that produced a lot of heat, and it always came. Anytime there was enough heat, it always came to the same results. You know, roughly between 65% to in the 70% range. The idea is that it produced a lot more, and then when you did it normally and you radiated it from the surface and you calculated Stefan-Boltzmann's law, and it came to much lower percentage. So the feedback loop was actually very effective, but only when applied more heat. Because if you didn't apply more heat, it would have to go. It was slower going through all that stuff. Now, with that said, that's interesting because my model shows it to accelerate, which is exactly what I saw in these controlled examples. That it showed it accelerating. Okay, so basically, the more heat that's applied, the more it accelerates. The less heat, less applied. So under normal conditions, like if you just get very little amount of heat, yeah, the feedback loop's not going to help it much. But the feedback loop is at its strongest because it is driven by the very heat that's being generated. The reason why my model is so effective is because of all the heat that's actually being produced during the global flood, which validated also a prediction that was made in my model straight off from the beginning, that this model is driven by the heat. It is driven by the very heat that's being generated. It's heat that's driving the mantle convections to go faster. It is as heat that's accelerating mantle convection and advection and pulling the heat at accelerated rates from the crust. It is the heat that's generating all this heat buildup, and it's pushing all this heat out from volcanic eruptions, making the volcanic eruptions much faster, much stronger, much more powerful, um, or more powerful, and all that heat is going into the water. More water is heat is being absorbed in the water. The hotter the water gets, the faster it is evaporated. Water is not a passive heat sink in my model. It's active heat sink. That all that heat that's going in is also really being released really fast via latent heat absorption, latent heat removal. It removes that heat as fast as it's evaporating. Increases the cloud cover at the same speed, increases the volcanic cooling, increases the albedo effects, increases Stefan-Boltzmann's law, or not the law itself, but it increases how much radiation is actually being released within 1 year. And so I thought that was pretty cool. It was a pretty cool series of controls. It's not the only one I've done. I've done several, but I like that one the best because it did actually show that happening. It showed that it showed when a lot of heat was working, it did actually get rid of the heat or get rid of that accelerated in my model. It showed an acceleration of every component in my model. As a result, it is driven by the heat. It's like I told you guys straight from the beginning, my model is thermally driven. It's thermally driven and it's a positive feedback loop. Those are essential to making my model work. When you take any one of those things out, my model would flatline, but it wouldn't really be my model. It would be a misrepresentation of my model. My model works because of those two essential key elements. Now the funny thing is, as their debates have gone all month long on this, none of the guys tried challenging those two things, and only recently, like very recently, they started to focus on some of the heat drivenness of the model, such as convection speed. Only then did they start challenging it recently. After all month to do it, and I've repeated it over and over again. But even then, they're not fully challenging it because Graham would, like I said, go back and admit, oh yeah, I admit that mantle convection does increase with speed, with increases speed with heat. The heat applied. Okay, then why wouldn't it be hard to realize that when you calculate those results, it comes to 170 billion times faster than normal rates? It's not hard to imagine if you can understand that there's a lot of heat buildup as a result of accelerated nuclear decay. Now, of course, Graham rejects accelerated nuclear decay, but it doesn't change the fact that if you were to consume it without to arbitrarily rejecting, just assume it for the sake of argument, then you got heat buildup inside the mantle that would make convections that fast. That's the point. All right. But anyway, I just wanted to throw that in that insert because I thought that was an interesting series of control. I've done others, but that was interesting, to say the least, because it actually validated another prediction of my model that it is driven by the heat, and the heat is what makes everything accelerate, and that's very important. All right, uh, thank you, and back to the video. The point is that they've had all month long to try to attack this, and they didn't. And so I actually did redid the test because that test was flawed. Not exactly for the reasons they did. I think AB's calculations were correct. I think ChatGPT told me right in one sense, but he was assuming the effectiveness of my model because my model is effective when taken as a whole, but the test itself wasn't because the test itself did not actually reflect my model as a whole. It did not reflect the actual system itself, which is a positive feedback loop that is driven by the heat, and that this is being fed back into itself and is combined with a number of cooling elements. It is important at this point probably to define what we mean when we talk about heat removal. Because in thermodynamics, the heat has to go somewhere eventually. But that doesn't mean how it gets there, however, is nothing entirely. Because heat, according to the laws of thermodynamics, heat can be transformed, it can be transferred, it can be delayed, it can be stored. So it's not necessarily like a one-way path to leaving Earth. When I talk about heat being stored in water, when we talk about even with the planet cooling over, you can still have heat in the atmosphere that isn't removed, and yet the planet could cool down significantly from these cooling mechanisms. So even that is allowed by the laws of thermodynamics. So I don't know why there's that confusion there. Graham should know this. He took a class on thermodynamics, so he thinks he's an expert. So if he's an expert, then he should know this. He should know that there are ways in which to cool the planet down. And but another thing, the reason why I say we have to define the word removal, okay, is because it depends on what you're referring to when you say removal. And I know what Graham is referring to. Graham is referring to like ultimate removal. Okay? And so that's why I want to distinguish one kind of removal is permanent or final removal. Obviously, the end game would be to get rid of the heat out of the Earth system. That would be the end game. That does not mean that that represents the whole game. There are other pathways that it could take before that heat ever is left the building. Okay, there are other ways in which heat can actually um, um, work its way in that direction. But obviously, it's going to do it eventually. But that's the end game. But it's not the only pathway in which heat can take. There are other pathways. And so, one type of removal that we can talk about is final removal or permanent removal. This is when the heat is completely removed from our atmosphere. Okay, that means it has left the building. It's not coming back. It's a one-way street out of here. Don't let the door hit you on the way out. Okay, that type of removal, which is what Graham refers to when he refers to removal. Uh, and the second type of removal is when you get rid of it from the problem areas. Because essentially the issue is really not the amount of heat. The Earth is capable of handling tremendous amounts of heat on a regular basis. It's really the time frame. Being able to do that in a short amount of time without catastrophic results happening. And in fact, Erica from Gutsy Giving, who popularized the idea of the heat problem on YouTube, actually leans on that argument. And talks about how the crust will melt and the seas and oceans would boil or vaporize and things like that. Of course, that all assumes that all of the heat is dumped in the water all at once and things like that, and no cooling mechanisms and stuff like that. But that is the goal. That is the real object here. Get the heat out before catastrophic results happen. Ultimate heat removal will happen, yes, but not before it needs to be removed from those problem areas. And so I define remove, and I distinguish between those two different kinds of remove. There's ultimate removal, there's final permanent removal. That's that first one. The second is what I call effective removal. This is where you remove it from those problem areas before it becomes a problem. The idea is that the heat is not trapped there, that there is a way for the heat to be removed fast enough. And this actually, at least I know on the speed of convection, something else I found out that I didn't know when I did the 150 zone test, that convection actually can make Stefan-Boltzmann's law more effective, actually, make it better to radiate out into space. Um, it actually makes it more effective. So, because of the faster convection rate and that sort of thing, and uh, um, the faster plumes are shooting volcanic heat out of volcanoes all over the world, more heat going into the atmosphere, and that sort of thing, and heat's constantly building up, and so it actually does make Stefan-Boltzmann's law more effective. And so that's interesting to note as well, something that I didn't know beforehand. So I end up redoing this test. I end up redoing this test to, and I split this up into three phases. Phase one, I called the heating phase, and the reason I called it this, and again, the description is the same. It's what same as it's always been. It's something I noted in some of my earlier tests on this particular model, and I realized that the cooling mechanisms don't really start to really take effect, like they don't really, you don't start seeing a real visible effect from these cooling mechanisms until that most of the heat sources have stopped. Most of the heat sources stopped generating at when the fountains of the Great Deep had closed at 100 and I believe that's 150. Is it 150 days? I think it's 150 days after. 120 days, 150 days, something like that. After the bounds of the Great Deep close, according to Genesis 8. And I think that when that happened, most of the heat sources stopped. Okay, the CPT was stopped either before or by then, for sure. So the catastrophic plate tectonics wasn't still going. Um, that the fountains of Great Deep obviously wasn't going. Um, uh, And I also put the meteor impacts there. Now, in truth, the meteor impacts could have been more spread out. The meteor impacts could be more spread out. I don't know whether they were or not spread out. They could have been. There's probably no way to know for sure. But just to kind of simplify the math, I just kind of put it all as one event within, early on in the flood sometime at some point. I don't know when they would have occurred. I would assume that they would probably spread out. If they do, that the heat source would be much more. It would be the same total, but uh, it would be more spread out. So you would have not as much heat here, not as much heat here, and so forth, and just be spread out throughout the course of the flood. Maybe later on I will check and see what it would be like spread out like that. But honestly, I don't see it being too much of a problem or being too off from the original numbers. So, assuming that Erica's numbers are even correct on the meteor impacts, I don't know if it is or not, but I decided to use the critics' claim, the critics' data, and then go with that. Again, at the end of the day, uh, the point is that it doesn't matter how many heat sources you add or take away. The heat is what drives this model, and taking the heat sources away lightens the heat burden on the cooling mechanisms, which causes a balancing effect, which does happen. Um, there was the reason why we was running all these different tests is because there was accusations being made by David, by Graham, and AB that my model violated the laws of physics. It actually doesn't violate the laws of physics. In a little bit, I'm going to actually show you my results on slides. I just wanted to explain all this first before we jump into the slides. Before I go into the slides, Before I go into the slides, I do want to talk a little bit about the rifle theory. Um, I haven't spent a lot of time discussing this with the critics because the vast majority of our conversations has been primarily directed to the GTF model in resolving the heat problem, and that's where about 99.9% of our conversation was. But Graham has tried to challenge the rifle theory in more recent. Now he's had all month to do this. They had all month to prove my model wrong. They didn't. Um, uh, you know, I saw them doing all kinds of silly stuff. I wouldn't be surprised if Graham saw my name misspelled, he'll swear up and down my model must be bogus. This credit symbol right off the bat, he put a Y there instead of an I. There you go. I must not know what I'm talking about. That's the kind of logic that these guys were doing. It's crazy. But now Graham did try to challenge my rifle theory a little bit. He brought up these four isotopes. They're usually the biggest hitters. He called them the big four, but they tend to generate the most heat, and they also tend to have a longer half lives to them. Like thorium 232, 14 billion years. Um, um, the potassium 40 is 1.25 billion years. I'm talking about the half-lives there. Uranium 235, or excuse me, uranium 238 is 4.5 billion years for the half-life, and and the half-life is calculated from the decay rate, so that shows you how slow of a decay rate it has. Uranium 235 is 700 million years on the half-life. Okay, and that's what, and so these were like the biggest hitters, and they're also the most abundant of these elements. Or they're scattered about in small quantities, but they're all over the world, and so these would be the biggest hitters. And so he says these are immutable. We've tried everything, we can't accelerate them. Therefore, just because you have these examples of isotopes that do accelerate, doesn't mean these do. And now, of course, now in reality, it is much more highly probable that they can accelerate. Um, it's about like someone trying to argue that um, if I have a hamburger and cooked, I'm talking about cooked hamburger, cooked frozen burrito. It's cooked, it's made, but it's frozen. And if I take the hamburger and I heat it up in the microwave for 3 minutes, it can heat the hamburger up. But if I try to heat the burrito up, I might wind up with either a frozen center or it being really cold, and then I have to heat it up longer, right? But the object of it is that Graham's argument is like someone sitting there saying, "Well, I guess microwaves don't work. Microwaves only work on hamburgers, at 3 minutes, but it doesn't really work on burritos." Now, it does work in reality. It just takes more time to work on it, right? You just have to sit there and apply a longer time limit to it, let the microwave sit in there longer, and heat the rest of it up. The microwaves work regardless whether it works on a hamburger or a burrito. It just simply a matter of more of those microwaves. Well, in this and like respect, what has been tried on them has been low to moderate type extremes. They haven't been the type of extremes that we see in other isotopes being tested. For example, these four have not been fully ionized. Okay, they've undergo partial ionization before, but not full ionization. And none of them have actually been tested with multitude of um, um, different tests, they haven't been tested with pressure, ionization, and heat to see how would they react if those things were being tested together. I would like to see that. That would be interesting to see, but they haven't. And so basically, the rifle theory would argue for a positive feedback loop that is scaling upwards and increasing with time, and so this would increase temperatures and that sort of thing, and increase the effectiveness of the loop every time more ionization is being caused, more heat being done, and more pressure, and it keeps increasing it. I'll probably do more work on the rifle theory later on down the road, But just in case if Graham decides to continue debating me in the comment section, the reality is that these things were not tested with similar extremes that were tested with other isotopes. Um, and it's not considering the catastrophic conditions of the global flood. The global flood would have been set into almost what scientists would call a plasma condition. I know people will hear the word plasma, they think starlight, like the sun or you know the core of a star or something like that. Plasma conditions don't have to be that intense. They can be, but they don't have to be that intense. In this case, what scientists would call plasma condition is simply a heavily sustainable ionized environment where ionization is happening all the time and you know such a way that the ionization is being sustained for long periods of time. And there's obviously a lot of heat and that sort of thing going on as well. And because of that, some at least in a localized manner, not in a global manner, but in a localized manner, there could be localized areas that were fulfilling like a kind of a plasma state that it would be in. A highly ionized area that's being sustained as ionized. And we don't see the plasma states being used on these four elements, these four isotopes. They are used on other isotopes, the plasma states and that sort of thing, but they have not really been used on this, not in the extreme at least, and that sort of thing. And now I did promise these guys, Graham, David, and AB, that they could have another shot at engaging me. Okay, but I got to move on from the subject matter. I've done 3 videos on it. I'm going to continue promoting this model. I've got another one out. It's not really, I don't count this as one of the 3 videos. It's more like, it's just like a short promo video that I did. I thought it was interesting to do that. Originally, I did it to show here, but I thought after I did it, I was like, wow, I can just, put that as its own thing. And so I did. And so it's just a short promo video of my model. I don't try to prove anything in that video because it's not that kind of video. It's not intended to try to prove the GTL model. I did that in these 3 videos. Actually, I demonstrated the GTL model in the first video. These 2 videos are primarily being to respond to critics. And like I said, Graham has a tendency to make categorical errors. He just kind of assumed that this would be like the third part of a video of my GTL model, a third version. Like no, that's like assuming that just because Donnie Badinsky from Standing for Truth has done a million ERV videos, that means he has a million different positions on the ERVs. No, he has the same position. He just made a million different videos about ERVs or responding to people on ERVs. Um, but that doesn't mean he has a different position on it every time. It just means he's responding to it. And same thing here. My model fulfills the laws of physics for sure. Definitely 100%. And like I said, I gave these critics a chance to respond to my arguments on this. Um, uh, I gave AB, Graham, and of course David, the YC. I said, okay, I'm gonna give y'all a couple more rounds each to respond to me on this. Okay, I have to move on from it. I've given you all month long on this, and y'all haven't disproven my model. I watched y'all jumped on typos, all kinds of other silly stuff. Get confused by how mental convection works, how advection works. You know, I actually even there's one argument that AB used, where he thought that advection could not possibly get out heat from miles of crust. And I actually Googled it, and it was right there on a Google answer, straight for first time. I didn't have to ask it additional questions or nothing. First question, it actually answered it and said yes. Even with miles of crust, advection will pull at the mantle crust boundary. Advection will pull out all that heat from the crust because crust is a poor insulator from heat. it will actually pull out all that heat. So even from miles across at accelerated rates. So, and it was like the first answer to the Google. It's like, golly, a simple search that AB could have done would have found out that advection can do that. Okay. Um, but in any given case, I told him I'd give him a couple more weeks. I'm not going to debate you much longer than that. I've got a personal situation I'm dealing with. I've got a load of interviews next month, like a ton, on top of me having to find a new place to live because so my family's dealing with a situation there. So Christians pray for me. We're trying to figure things out. But in any case, I'm not going to continue the debate. But I wouldn't have even done this, to give them a few more rounds because we have gone all month on this, and I am tired of it, and I want to move on. But I promised them that they can have another chance of engaging me. So I'm going to give them that opportunity to do just that. Um, but if they don't take me up on it, okay, I will give them till not this Friday, but next Friday. I think that does put us right into the beginning of August. But I'll give them till next Friday. I'm going to try to quickly edit this video, give them to next Friday, and they'll have till then to do both rounds, okay, each. That way I will know whether or not if they will do it. Because I don't know. See, with AB and Graham, I'm almost certain that they will. With David, I'm not sure. Um, David sounded almost like he was bowing out of the discussion the last time I saw any comments from him. So I don't know whether he is going to be participating anymore or not. It's up to him. But if he does, I will give him 2 rounds, just like I'm going to give AB and Graham, to be fair. Now, Graham sometimes has a tendency not to want to stop because he hears things he don't agree with, and he thinks that this gives him license to keep on arguing about it. He's like, well, if I hear things that are falsehood, it's not false for start with, and second of all, it does not matter because if you sit there and try to keep on debating me over things you don't agree with, we're gonna be here all day because you don't agree with me, I don't agree with you, and so we keep fighting back and forth over it. So it's not gonna do us any good. All right. Eventually, the debate has to end. I'm sorry, you guys. Y'all have had all month to disprove it, my model, and y'all misrepresented it. Y'all jumped on typos. Y'all did some weird arguments, factually inaccurate arguments, and y'all did some good stuff too. But if you really want to challenge my debate or challenge my model, I will suggest one, attacking the system as a whole. Two, attack the fact that it's thermally driven. It's a heat-driven model, okay, a heat-driven system, and the fact that it's a positive feedback loop. These last two right here are fundamental. So I've always given you guys all the tools you need. If my model could be disproven, I've given you guys the means to do it because my model is dependent. It's dependent on the mechanics. It's not dependent on the math. I've told you that. Stop trying to challenge the math. It's symmetrical approach, not an asymmetrical approach. So stop challenging independent components. Challenge the system as a whole. Challenge the system. Challenge the fact that this is a thermally driven system. It's driven by the heat. And challenge the fact that it's a positive feedback loop. My model is dependent upon that. It would flatline, completely flatline, if these things were not valid. Okay? So my model is absolutely dependent upon it. If my model could be defeated, that's where it would be defeated. So that is my challenge for you. As you make your next couple rounds, next couple of rounds of engagement with me, make them count. Make them count for something. Stop trying to find mistakes in one of my slides or errors in a typo, or silly arguments. I would never argue, like assuming that I think that energy is going out into space without without going through radiation or something, or being radiated, which I've never said, including in my original video. Stop putting words in my mouth. Stop nitpicking over every last little thing. I'm surprised no one's nitpicking on how I spell my words or something. That's how silly some of these attacks have been. Focus on what is matter. What's going to matter? I have given you the tools to do it. If my model could be defeated, I have just handed you the tools to do it. But can my model be defeated? That's the question. But anyway, I'm going to show you my slides real quick. Give you the scientific data on this, that on the figures that we ran up on me and ChatGPT. All right, here it goes. All right, the first slide I've got is just kind of like comparing the old test with the new test that I did. The new test I did with the three phases. The first phase is called the heating phase. Second phase is called the cooling phase. And because the cooling, I probably kind of got off on the thing, but the first 5 months of it is called the cooling phase. The heating phase, because that is where most of the heat sources are. The second phase, phase two, is called the cooling phase. It lasts 7 months. The flood year, both the heating and the cooling phases is in the flood year, and it's 7 months long. And it's called the cooling phase because that's when the cooling mechanisms really start taking effect. It's still now these phases overlap with each other, of course. Um, because you still have cooling mechanisms that are taking effect in the phase one, and you still have heating sources in phase two. The heating sources that continue in phase two are going to be accelerated nuclear decay, although in a much weaker degree, and um, and volcanic heat, and of course convectional friction still going on. But the convectional friction would actually be less during this time. I did not factor that into the calculations, but if it do, it'll just kind of go less, and it'd be less heat involved in phase two. But and then post flood is what I call the removal phase. Okay, that's when the final removal happens over the course of 30 to 50 years. This didn't really represent my model very good. The second test reflected my model very good. All right, here's the figures here. The total heat. Now I do have this redone and recorded on my GitHub account. You critics, can still use the same link for it if you don't remember it or don't want to go through a million replies to find it. I will have the GitHub link linked in the video below that will actually have these same figures in there. But anyway, the total heat generated during the flood year, of course, 1.81. That hasn't changed since I did the second video. In phase one, the heating phase, first 5 months, it removed 26.1% of the total heat. 0.261 times this times 10 to 30 power equals 4.7365653692124969 times 10 to 29 joules, or 26.1% of the heat. Phase 2, cooling phase, final 7 months, removed 50.9% of total heat, and it gives you the math here, so you can see how the figure is, how much it actually removes during that. So it moves like 50.9% of the heat. Okay, this leaves phase 3, post-flood removal phase, remaining 23.0% of heat removed after the flood, and you got this number. The total amount that's removed permanently before the end of the flood is 76.77%. It's not on here, but you'll see it in a little bit. but it's 76.76%. Of course, if you figure all this up, that's what you're going to come up to, 76.77%. All right, so it's basically the amount that is permanently removed. That is not the amount that is removed total from all problem areas. So the effective removal is actually over 99% removed. That includes permanently removal plus all the heat that's being removed from those problem areas, from the interior of the earth, from water, um, uh, uh, the volcanic eruptions and things like that. All that heat that's being removed at a rapid rate based on my system is over 99%. So it actually alleviates over 99% of it, and it combines the cooling mechanisms to cool down the planet and that sort of thing. So you wind up with that. Those are the stats. Okay, here's a pie chart. You see right here, 76.8%. That's rounded up a little bit. And you got 23.2%. And this right here is the remaining post-flood phase 3. That's the leftover heat in the atmosphere, not in the crust of the earth or in the water or anything like that. That is how much is left in the atmosphere by the time you get to post-flood period. And that remains to be descended from the flood. Okay, here's the different heat sources you got. You can see accelerated nuclear K is far greater than everything. David tried to argue that he thinks the CPT is the highest heat source. It's not. I can understand why someone would want it that way. Graham tried to get me to force me to reject accelerated nuclear decay in order to quote unquote resolve the heat problem. Most critics will still argue that this would still cause a heat problem. Baumgartner has argued that this would cause some kind of heat problem with the catastrophic plate tectonics. So I wouldn't necessarily sit there and argue that that getting rid of this would solve the so-called heat problem to begin with. But secondly, I would not argue for this to be this would be um, that 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 we have to ignore evidence that we have for accelerated nuclear decay in order to avoid a so-called heat problem. No, it's just simply a matter of having a mechanism or component, or in this case, a system of mechanisms to be able to alleviate the heat. And yeah, it's a lot of heat. Yes, I understand. It's an incredible amount of heat, definitely. But it doesn't mean that it's impossible to get rid of that heat. It is a lot, but it doesn't mean it's impossible. I don't ignore evidence just to avoid having to deal with objections that critics make or something like that. You know, I accept the evidence of Jesus' resurrection, even if a critic doesn't like it and decides to throw out 10 objections. I'm just going to respond to those objections. You know, so I don't do that. That's not me. Um, but there's strong evidence for accelerated nuclear decay. Yes, it is the greatest of all the heat problems, or all the heat sources, I should say, all the heat sources during the Genesis flood, definitely. But it's still manageable within the GTL model. Here's a representation of the different heat sources. And you kind of see like a line graph here. These are just line graph that represents this right kind of represents meteor impacts. Right here, yeah, meteor impacts, because it's kind of like a sudden heat kind of deal rather than a long continuous heat source. Okay, here's another slide. Talk about my GTL models and the test that was done on the heating phase, the cooling phase, and removal phase. In the heating phase, I wrote all 6 major heat sources active. Accelerated nuclear decay, subduction, runaways, talking about the CPT, meteor impacts, volcanic activity, the fountains of the great deep, mantle convection, friction, and this is the how fast the speed is. Again, this is only at its peak. cooling mechanisms already fully active, our EM radiation begins. Um, and this is a misconception that might happen, kind of like I'm anticipating misconceptions. These mechanisms do kind of overlap with each other, but the cooling mechanism is still operating during the first 5 months. Then you got uh, Then you got the cooling phase, heat alleviation lasts 7 months. Heat sources taper off. Only accelerated nuclear decay, volcanism, and convectional friction remain, and drop significantly by the end of flood. Cooling mechanisms dominate rapid evaporation, cloud formation, latent heat removal, albedo effects, massive REM radiation continues. Heat sources still exist but are diminished. Cooling dominates. Cooling phase does not equal no heat because it still has heat there. It just much more minimized. Then you got the removal phase, remaining 0.26% of heat. Our EM radiation removes heat into space. Cooling mechanism persists through declining. Volcanism, albedo, cloud formation, oceanic heat absorption, post-flood ice age dynamics. Of course, I don't add the post-flood. This is something ChatGPT wrote, but I don't add the post-flood ice age to it because I don't want to add compiled assumptions on top of it as far as adding it to my model. But the ice age would actually help with the cooling following the flood, and the ice age occurred following the flood. Alright, cooling mechanisms remain active. Volcanism still contributes heat. Positive feedback loop weakens but continues. Our EM governs final exit of energy. Okay, here's another diagram here of the overlapping of the phases of the GTF model. Phase 1, the heating phase, primary focus, heat generation. Key characteristics, all 6 major heat sources are active. Accelerated nuclear decay, um, which I don't know. Yeah, right. Accelerated nuclear decay. Why did they got "and" here? I don't know. This is a mistake. This is ChatGPT one created. This is a mistake that ChatGPT did. I just now noticed it, but I'm pointing that out simply because I know how Graham is. He said, "Well, you got accelerated nuclear decay twice, therefore my model must not be true." It's like, nope, that doesn't work either. Don't waste your rounds saying stuff like that, Graham. Please don't. Please don't. This is an obvious typo. I didn't even notice this until now. I was like, oh, it put accelerated nuclear decay twice on this diagram. Okay, but it's not anything major. It's not a major problem. But I know my critics, they'll turn it into something major. CPT, subduction, runaway, volcanic activity, pounds of great deep, mantle convection friction. Yeah. Misconceptions, cooling mechanisms already operating, purely heating. Now you got phase 2, the cooling phase. It seems to have some typos in this particular slide. I don't know why. Last, because you see here is a capital L and then you have a lowercase l. It's like, why is it like that? I don't know. Last 7 months of the flood. Key characteristics, heat sources taper off. Only accelerate nuclear decay, volcanism, and convectional friction. Um, remain. This is cut off here for some reason. Accelerated nuclear decay drops significantly by end of flood. Dominate cooling mechanisms. Dominate rapid evaporation, cloud formation, latent heat removal, albedo effects, misspell effects. I think that's supposed to be a T. Massive REM radiation continues. Post-flood ice age dynamics. This is just referring to the post-flood ice age after the. It's not really part of my model, but it does follow the global flood. And in phase 3, the removal phase, final dissipation, post-flood decades. Misconceptions clarified. Cooling mechanisms remain active. Volcanism still contribute heat. Our EM governs fall. All right. So now you got this cooling mechanism, different stats. IREM released into space, 76.77%. Cloud albedo, phase one, heating, and it gives you that. And so if you want to record these, you can. It gives you the latent heat removal, how much of the flood water is absorbed. And the total is 99.1933%. What this is referring to is the total of all uh, um, uh, effectiveness of the whole system as a whole. So, in other words, it's including both permanent removal and effective removal, where and combined with the cooling mechanisms, how much it's going to cool off the planets, how much heat is actually going to be effectively removed, like in latent heat removal via rapid evaporation, and that sort of thing. And so when you combine all this, it does come to 99%. That includes critics, the 76.77%, in case someone says, hey, look, all this doesn't come to 99%. Well, I'm not saying it's just this. I'm saying this and this. So it's a combined effort here. So that's what that is. It's including both the permanent removal and the effective removal um, heat that's being removed from the various source of very areas of the Earth that are problem areas, as well as permanent removal of this heat for good into space. All right, my voice sounding all raspy is because my throat's actually getting dry. Okay, here's phase one test results. You got the cooling mechanisms, heat removal, effectiveness notes like okay, our EM radiation to space. Initial radiation begins to due to upper atmosphere heating, but fully dominate later. This is how much heat is alleviated, or more specifically, permanently removed in phase uh, one of the phase three phases. Okay. This also got has the latent heat, has the cloud and albedo, um, has volcanic cooling, the floodwaters, volcanic heat expelled to atmosphere and oceans. You got the total heat removed in phase one as 21%. Okay, this is phase two test results. And so you got 71.77%. The 76%, by the way, 76.77% is the combination of phases one and two, just so you know. And as soon as I say that, some critic like Graham is going to say that isn't 76%. It's like this is phase two's total heat that's being alleviated, which does include phase one. The 76.77% is going to include phase one, as well as phase two. All right, so that's why this is lower because this is only phase two. How much heat is removed in phase two, which is much more effective, obviously, than phase one. Phase one, you still got heat building up and that sort of thing. Um, Latent heat removal by evaporation, cloud albedo. This remember these are all stats during the phase two. Okay. Um, and then you got the total heat removed from phase two. This right here, I think I think it moved it up like 0.10 by accident. I'm not exactly sure what this is. But this right here is the total removal from phases one and two. This right here, um, I think this is the total heat if you include move from phase one, if you include other parts of the system, not just the final removal, but other the effective removal as well, and that comes to 77.87%. But the total that's removed, that means combining this and the amount that's permanently removed in phase one is 76.77%. Phase 3 test results. This is post-flood. You see a bunch of zeros. You might wonder why in the world is there a bunch of zeros down here? It's because it's getting to a point where even though these processes are still working, it's not really having to work as much, or the amount is so super negligible that there's no point even referencing it. And so you don't have these. These are operating, but the effectiveness of them is not going to be as strong. Not just because the feedback loop is weakened, but because the heat is weakened considerably. Because this is less than 1% of the heat that's still needing to be dealt with in terms of on Earth. Not permanent heat, but because I think it's like around 23% of the final heat needs to be dealt with, and this is but less than 1% would have to be alleviated during the course of the or during the next 3 to 5 decades following the flood. So these are zero out because of that. So there's like 0.8067% that's removed, and that's the 1%. This is talking about effective and permanent removal. And so, or effective removal. So at the final 0.8067% of total heat space into over 30 to 50 years. Evaporation condensation continues, but already in previous phases. Albedo effects persist but prevent new heat input, not removal. Minor post-flood eruptions continue but negligible for total heat balance. Acts as thermal buffer, not a permanent sink. Heat is still eventually radiated. Heat continues to move through the crust mantle but doesn't change removal total. Final removal of all heat, residential heat, 0.8067% via long-term REM radiation. Okay, this is convection, advection speeds. Get the phase, convection speeds, advection speed. Um, and these are these numbers. My voice is starting to lose traction here, so if I just seem to be speeding this through, y'all can just kind of pause the video if you want to and take a note of these numbers if you want to look at them later. All right, and this is kind of like a showing of how advection works. Advection is the process of moving heated material. It's different from convection, which is like the flow of heat through a um, liquid or something. Advection can move heat through a solid because it physically kind of moves that heat with it. And here, right here is the mantle and crust boundary at the bottom, and you can actually pull heat all in the crust and just kind of pull it into the mantle and it to expel it volcanically. Here's another image. I got several of these images here. Shows you how convection works and how heat is transferred um, to the it says heat transfer to the crust, but it's not transferring the heat to the crust here. It's actually pulling heat out of the crust. Increased volcanism, advection, convection. It's all set on a positive feedback loop, a geothermal feedback model. Volcanic eruption expels heat, convection, advection, mantle. Geothermal feedback model, mantle plumes, convection, core. You kind of see there's kind of a neat picture here. But all this heat's being expelled by volcanism. Okay, here's the advection speeds, GTF model versus mantle, modern mantle convection. You see advection speeds. These are two different speeds here because ChatGPT calculated a minimum speed advection as well as a maximum speed of advection, and it's based off the speed of the current speed of the mantle convection, at least at its peak. And so that's why you get this. This is modern rates as compared to modern rates. Then you got convection speed across the three phases of the GTF model. See, this is phase one, this is phase two, and phase three. This compares convection speeds, modern versus GTF model phases. You got the modern. This is again convection speed at its peak, and then you got phase two. This is what the convection speed would be because it would be lower because of the heat source is less. Um, and this right here, phase three, heat source is even less. So you expect convection to go downhill like that, decrease. Okay, convection versus advection speeds across the GTF model phases. You got the different convection and advection. This is advection, this is convection. Again, this is at its peak. And you got this right here in the modern sense. And then you got convection and advection right here in phase two. And then phase three. Okay, here's a pie that shows the removal rate here. This right here, the 94% right here represents total removal, including the both the final removal and the effective removal um, heat of the heat sources. Here's my rifle feedback loop under extreme condition diagram. This is just shows my rifle theory, how that works in ionization. All right, I did a recent video, um, but y'all can watch that on my channel if you want to, because I released it as a separate video. All right, that's it for today. That's it for now. I'm gonna give these guys a chance to spawn. I should have this video out hopefully by this coming Friday, um, and see what you guys think. And like I said, Graham, AB, David, 2 rounds each. Don't spend a lot of time focusing on mistakes in the slide. Say, oh no, there's a mistake in the slide. That means that me and ChatGPT don't know what we're talking about. Don't do that. Okay, you're just gonna waste your time doing that. Don't waste your time trying to focus on the numbers. I know I gave the numbers. That illustrates my point. But if you focus on the numbers, okay, my model isn't math dependent. Even if you found a genuine error in the math, as soon as you correct for that error, it's going to all snap back and it's going to still wind up being mostly heat. My model is going to be true no matter what because the system itself is valid. You need to deal with the system. Do not take your last few rounds and waste them away by attacking and nitpicking at the silliest little things. Okay? Don't do that. It will be pointless. It will leave you debating about it in a contentious fashion, but it will not be able to be successful because all you're doing is nitpicking at a slide or nitpicking at something that was said or wasn't said. Don't waste your time doing that. Focus on the important stuff. I've told you what you can do to focus on the important stuff. Um, I would recommend doing that because you only have a couple rounds left. I really cannot go beyond a couple rounds. And even then, you only have until not this coming Friday. Not the Friday this is supposed to come out, but next Friday. Okay? All right? So hopefully, y'all will. I don't know. It all depends on if y'all want to continue replying. That's fine. And Graham, if you want to continue to debate me on the rifle theory, we'll debate a little bit, but it will count as your 2 rounds. Okay? No exceptions. It will count as your 2 rounds. Okay? If I was you, if you wanted to debate me on the rifle theory and the GTF model, I would just combine them in the same reply. That way you can kill two birds with one stone. You can still debate me on it without wasting your rounds. But I'm not going to dedicate any more time on this. I got to move on. I'm getting tired. I'm getting tired of making all these videos on this. I've got other videos I've got to make. I've got next month. I've got a ton of interviews. I got a new mini series that's out now, and I'm tired of debating it. To be honest, you, me, Graham, AB, and David has debated this all month long. I've given you an entire month to disprove my model, and you haven't done it. And I can't stop it. You know, I can't be able to change that. You know, and now here we are at the rear end. It's now or never. This is where the rubber meets the road. All right, you're going to have to produce a result, a conclusion, you know, effectively that destroys my actual model, not a misrepresentation of my model, not you nitpicking at a slide, a misspelled word, or whatever the case may be, or arguing something silly, but actually deal with what my model says, represent it correctly, deal with the system as a whole, and be able to disprove it on the basis of what it actually says. Like, here's what the model says, and this is how we can prove that what it says is incorrect. And if you focus on numbers, that's not going to do you any good. Because as long as, you know, as long as everything I say about the system is true, then all the numbers are going to follow suit every single time. Even if you found a genuine error, I corrected that error, everything's going to click back into place, and we're going to be back in square one. And I don't want to continue for another month debating this topic matter. So you guys have exactly 2 rounds, and even those 2 rounds are limited by this upcoming Friday. Okay, not upcoming Friday, but the Friday after next. Um, I believe that will take us into early August, like very early August. Um, maybe either at the end of July, right at the end of July, or right at the early August, or somewhere in between. You know, between those 2 months. Um, and then that's it. I've got to focus on other things. I'm sorry, guys, but you've had all month to do this. And I watched all kinds of silly arguments come out of it. But you guys have got to buckle up, and if you want to challenge my model and respond to it and defeat it, you're going to have to deal with what my model actually says, the system as a whole. And you also have to consider the very real possibility, the reason why you have not been able to defeat my model yet is because of the fact that my model actually does work to alleviate the heat. You have to consider that possibility. You might not want to consider it, but you have to consider it at the end. All right. I just wanted to add this in. Right now, my model is the most powerful model ever produced on the heat problem, so-called heat problem. Why is that? Well, one reason's obvious, because it gets rid of all the heat. The vast majority of it gets rid of before the end of the flood year. The rest of it safely mitigates over a few decades or so. All right, and so that's one reason why it's so powerful. Another reason is because it's thermally driven, so it really doesn't matter if critics wants to try to throw in heat sources, whether real, imagined, artificial. It's not going to really affect it much. The only thing it's going to be affected is maybe how much heat is managed alleviated within the year. You know, obviously the calculations would change, that sort of thing. But it would still alleviate most of the heat by the end of the flood year, and the rest safely mitigated over time following the flood. All right, spread out through a variety of different processes. But the numbers that are being raised right now show clearly that most of the heat, the vast majority of it, is so much taken care of that even though these processes are still going on following the flood, they don't really have to really go into overdrive the way the flood did. And so the conditions of the flood would have created this positive feedback loop. Another reason why this model is so powerful is because it's consistent with all popular models and that are well evidenced and well argued for, things like the CPT, the accelerated nuclear decay, it is totally consistent with all of these different various YEC models without having to abandon anything. You don't have to abandon the CPT, you don't have to abandon accelerated nuclear decay, you don't have to revise things like David Winberg, I think, whatever his name is, David's model revises the Ice Age. He thinks the Ice Age started, I think, within a couple of hundred years following the flood, and he has to stretch the time level to hundreds to possibly thousands of years later, or something like that. It's really heavily stretched over time, and it kind of pushes the Ice Age out. And even Mike Ward argues for his Ice Age early on. So if you look at that, it's just not. It requires him to revise models. He even had to abandon accelerated nuclear decay. He says he's not doing it for the heat. That's what he told me. But he says he doesn't think it's viable, but he doesn't give any kind of explanation why he doesn't think it's viable. In all honesty, I think that it's because of the heat that he doesn't want to invoke that much heat. He doesn't say that outright, but I think that's what it really comes down to. Because the accelerated nuclear produces a lot of heat, and that's usually the reason why they abandon accelerated nuclear decay. I don't do that. There's strong evidence in favor of accelerated nuclear decay. I think it's part of mainstream YEC positions. Most YECs would hold to accelerated nuclear decay, as do I. It is strongly evidenced, and because of that, I know that accelerated nuclear decay happened. But now we actually know that how all that heat. In fact, that heat would have been a massive driving force to its own removal because of all that heat. Because of the fact that this is thermally driven, it's driven by the very heat that's being produced. And so that's another reason why it's so powerful. It's very consistent with these models. No YSC should ever feel like they have to abandon a particular argument, whether it be CPT, accelerated nuclear decay. Now, since proposing my model, making public, I've had a variety of different reactions. And the reactions have been kind of mixed. Some YCs have been very encouraging, very supportive of it. So wow, that's pretty cool. And then you got others that have it, or you got seculars that have it, and it's like, okay, what's going on right now? I understand why the critics are like this, but why is some YCs like this? The reason is because this heat problem, so-called heat problem, is has gone on for a while. It's something that has been around for a while, and because of that, different YSCs have proposed different things. Either they've already made up their mind to abandon certain ideas, certain arguments, certain positions, etc., or they've already adapted to a particular model or idea or something like that. And because of that, this makes them a little bit more committed to a particular position and have so and probably argued for it publicly before I ever proposed my model. This will also mean that it would make a lot of people closed-minded to it. And that's what I'm afraid of, that people will be so closed-minded to it that they won't even consider it. Despite the fact that this is based on observational evidence. It's based on evidence involving volcanic eruptions. It's showing that this heat demonstratably would be effectively its own removal because of how much heat is being produced during the flood. The conditions of the flood would have created a positive feedback loop, and all the events that are happening during the flood would have created that positive feedback loop that would have actually included cooling mechanisms and would have actually gotten rid of the heat. And there's no doubt about that. No doubt at all in my mind. And unfortunately, this may mean that some YCs are not going to be happy with me. Okay, I can't help that. I hope to God that y'all would continue watching my channel. I agree that maybe y'all committed to a certain idea. You commit to a particular position, and you know, and you just never thought about putting it on a positive feedback loop. You just assume, oh well, it has to take a lot of time. No, it doesn't necessarily have to take a lot of time. It might take time, don't get me wrong, but it might not have to take a lot of time and that sort of thing. But the positive feedback loop shows that these mechanisms are working together. And a lot of times, I had a critic contact me at one point and says, "Don't you know that the heat problem is made overwhelming because of the math? The math makes the flood situation impossible." And I'm like, no. Um, now, now, in a sense, in a way, if it is true that if all the the heat, see if I can say this the right way, that the mechanisms, the components alone, it is true that the components alone would not be able to take care of the heat problem in and of itself. But in my model, none of the mechanisms and components are by themselves. They're all working together to alleviate the heat, which means you do not have to put all this heat on one particular component ever. It's not even necessary. And it also means that it's not necessary to abandon popular arguments that are well evidenced and are good arguments, and you just say, well, I'm just going to abandon them because there's just too much heat, and I don't want to have to deal with that much heat. This model takes that heat and turns it against itself. The heat becomes its own dissipation method. It literally dissipates the heat. The heat that's generating it is what's driving the system. It is the driving force of the system. And because of that, there is no reason, no excuse for YECs to abandon good models and good arguments and good positions to adopt other views just because they don't want to deal with this heat. There is no reason for it. There is no more excuse for that. And it saddens me when I see YECs doing this. It's like, why are y'all doing this? Okay, yes, Erica popularized an idea on YouTube. Okay, granted, she gets full marks for making this argument, popular idea, popular conversation piece, whatever. But it is made invalid by my model. My model shows that the heat can be alleviated, the vast majority of it, before the end of the flood year, if everything is set up on a positive feedback loop, which we know it would be, given the conditions of the flood. Guaranteed. There is no more reason for any of you guys to abandon things like accelerate nuclear decay, abandon the CPT, revise models, and revise the post-flood ice age model, or anything like that. You can accept every one of these models and it'd be 100% consistent with the GTF model, every bit of it. So yeah, I don't agree with this whole idea of abandoning models just because critics have a problem with it. Because think about it, if I had to abandon models, abandon ideas and positions just because critics had a problem with it, I wouldn't believe anything at all. Because critics have a problem with everything that we say. They have a problem with the resurrection. They have a problem with the Bible. It's like, what do you believe? Well, I don't know anymore. Critics have a problem with everything. I used to believe the Bible, but they had a problem with that too. But I don't believe this mentality that just because critics have an issue with it, that I have to sit there and abandon it. No, I don't do that. Now, if there's reasons to abandon it, real justifiable reasons to abandon it, then I would. But this is not the case. There's no justification for doing that. To begin with, even before we even knew what the mechanism was, it was just simply a matter of having a mechanism. It doesn't mean that a mechanism doesn't exist if we don't know about it. It just means we don't know about it yet. More research needs to be done or something like that. But it doesn't mean that the mechanism itself didn't exist. We have evidence for accelerated nuclear decay. We have good reasons to believe in catastrophic plate tectonics. We have good reasons to believe in meteor impacts during the flood. I mean, we have good reasons to believe in these things, and we have good evidence that global flood did occur. And we have reasons and justifications for all of these different heat sources, but we also have evidence that no heat was uh, um, that no heat ever that there was never actually a legitimate heat problem that would have generated enough heat to melt the crust or destroy the oceans or whatever because we have the presence of fission tracks and polonium halos, which would destroy at a certain degree. That means the crust has to be relatively cool to where it's not the heat's not lingering, where it would melt the crust. Because if it was to the point of melting the crust, this evidence would be destroyed. So we know that that would not happen. So if we have evidence of these heat sources, but we have evidence that it did not have that the heat itself did not destroy this evidence right here, then that would mean that there must have been a mechanism by which to get rid of the heat. That's an argument that was used by Dr. Andrew Snelling himself in his book. I don't have his book out; it's on my shelf, but it's Earth's Catastrophic Past. He used that argument there. He also referenced it in a interview with me when I talked to him about the so-called heat problem as well. He's mentioned it in emails as well to me. But that position does still stand. So even if you did not know what that mechanism is, we know that the mechanism existed, regardless of what it was. We know that it what did, regardless. Um, but now we do know what that mechanism was. But whether we know what that mechanism was or not would be irrelevant to it existing. I don't know what the critics had for dinner last night. Doesn't mean they didn't have dinner. So the mechanism still exists. We just didn't know about it up until now, or didn't think about it. But now we did, and the heat problem's going on for some time, and people's already, I kind of came in at the late end of the game. So where does that leave us, though? Because now you got critics that don't want to to concede to my model because because heat problems popularized. They want to keep heat problem as a challenge. But if I answer that challenge and respond to it adequately and satisfactory, where does that leave their so-called challenge? Where does that leave the so-called problem here? It throws it away. It destroys it. And you know they don't have nothing else to do. So they're not going to sit there and let go of that problem so easily. Let go of that so-called problem so easily. Um, and what about YCs who have abandoned good models or good positions just because something invokes a lot of heat? My advice to you is that YCs should stop abandoning good ideas just because critics have a problem with it. Because it's weird that when it comes to certain things that we have easy responses to, that we can respond to, we have no problem in rejecting what critics say. It's easy to reject what critics says when all of their own data supports what we're saying, right? Um, but when we reach a challenge and we can't figure it out, or we don't know the answer to the question that's being asked of us, all of a sudden it's like, well, I don't want to have to deal with that. but yeah, I want to respond to the critics. So what do I do? So, and then you just kind of just start abandoning ideas that would just kind of keep you from having to make that response to those critics. And I'm not like that. I'm not one of those people that would run away from a challenge. Um, and this was I'll have to give critics their prop. This is a challenge. It's probably the most challenging objection they've ever raised on the global floor. Most of, I mean, if we're being honest, most of their attacks are straw man arguments. You know, they just misrepresent us left and right, um, or they're factually inaccurate, or they're misinterpreting certain evidences, or something of that nature. But or they're just ignoring the evidence entirely. Um, but with this one was a real challenge, and that's one of the reasons why a lot of YACs went to try to abandon models, revise ideas, things like that. Um, in order to try to avoid the amount of heat that's involved in it. And I didn't do that. When I did my GTF model, I knew straight off the bat what I was doing. In fact, the first heat source that I was really aiming for was accelerated nuclear K. I aimed for the biggest heat source during the flood. I did not aim for the smallest little heat source to try to come up with a solution and then ignore all these other heat sources. I went for the big kahuna. I went for the big dog. That's what I went for. Then I realized my model cannot just solve for accelerated nuclear K. It has to solve for all the heat sources during the flood. And that's when I went into researching it. That was my thinking on that, because I'm not one of those people that will run away from a problem, run away from a challenge, or run away from an objection. I don't do that. Now I might not know something about something, and I'll be honest with you, and I'll tell you I don't know that much about it. You'll have to, talk to someone who does, and that sort of thing. But when I went to research it, I made sure that I was directly hitting the topic matter. I'm not one of those people that just tries to avoid dealing with an issue. I just deal with it straight off. Okay, that's just the way I am. It's just the way I'm wired. But it is what I did, and so I do believe the GTF model is a really good model. It is excellent. It is strong. It's well supported. I like it. I hope you guys do too. And the ones that don't, I hope you can at least try to give it a chance. Okay. I understand it's not your normal cup of tea. You've already committed yourself to a particular idea of the so-called heat problem. Whether it be a particular model, or whether it be banning certain arguments or whatever. But uh, I would recommend you at least try to keep an open mind when you view it. It is well evidenced. It is a very strong argument. It is hard for the critics to even go against. I've been debating this with these critics all month long, and they still have not defeated my model. So I say that's a win in the right direction. But in any given case, I do want you guys to make sure you like the video down below. And that helps the YouTube algorithm, helps get this information out to more people. I am almost at 300 subscribers, so if you have not subscribed, please subscribe to my channel and share this content. I have supporters would contact me and tell me, say, I just shared this video on my channel. I just I share it in the community page. I get this information out there. Let people know about these videos. Absolutely. I encourage you to share my content on your community pages. Share it with your viewers. Share it with your subscribers. Let people know where to find my channel. And I appreciate the support. Any support you guys give me. I love you all very much. Thank you, and I appreciate it. Um, but anyway, that's all I got for you today, and I hope you guys um, enjoy it. Enjoy discussing this with me. All right, see you on the next one.